Hello all, today we discuss about what is thermodynamic probability. So this is very important parameter and it is applicable in a Bose-Einstein statistics or MB statistics or FD statistics, permitted statistics. It is also known as thermodynamic frequency or also known as probability. So this is very important, probability. Okay. So the number of microstates corresponding to any macrostate is called thermodynamic frequency. It is denoted by capital W. So what is the definition? The definition is know that the number of microstates corresponding to any given macrostate is called thermodynamic frequency. The number of microstates corresponding to a given macrostate is equal to the number of meaningful arrangement or permutations of various particles in the macrostate, excluding those permutations which are meaningless, that is, merely interchange the order of the particles in a particular compartment or cell. For the case of n number of particles and two compartments, if we consider there are n1 number of particles, total number of particles equal to n, and we consider n1 number of particles in the compartment number 1, so this is compartment number 1, and say consider n2. What is the value of n2? This n2 is basically n minus n1, so consider this particle will contain in the compartment C2, sorry, this is C2. Then the number of meaningful arrangement is, what is the meaningful arrangement? This is n factorial divided by n1 factorial into n2 factorial. Okay, so this is a meaningful arrangement. So now we again write this equation by this expression. This is n minus n1 factorial also. Okay, this is n1 factorial. Okay, therefore the number of microstates in the macrostate, that is n1 comma n minus n1 or n1 comma n2, that is the thermodynamic frequency or probability. So this is defined by W in a bracket n1 comma n2, that is equals to n factorial divided by n1 factorial into n minus n1 factorial, that is also represented by this equation n combination of n2. Okay, these also are also expressed in combination of n1 also. So this is a concept of thermodynamic probability. For example, there are 5 distinguishable particles for the macrostate. For the macrostate 4,1, there are 5 distinguishable particles, and one macrostate is 4,1. That is, in a one compartment 4 particles are available, and one compartment is only one particle. That is n1 here equals to, sorry, that is here n1 equals to 4 and n2 equals to 1. Okay, now thermodynamic probability. What is the thermodynamic probability for 4,1? So what is the value? This is 4 factorial divided by, sorry, this is a 5 factorial, because n factorial divided by n1 factorial. So that is 4 factorial by 1 factorial. So what is value of 5 factorial? 5 factorial means this is 5 into 4 into 3. This is 120, and this is 24. This value equals to the 5, and now we again say that this is the thermodynamic probability values for 5 distinguishable particles, and one compartment contain 4 particles, and another compartment contain 1 particle. Okay, so the probability of a macrostate is defined as the ratio of number of microstates in it to the total number of possible microstates of the system. The total number of ways of arranging n distinguishable particles in c number of compartment, that is equal to c to the power n. N number of particle arrangement in a c number of compartment, and if there are only 2 compartments, then this formula is equal to 2 to the power n. Then for 3 compartments is 3 to the power n, and so on. Okay, now from here the probability of occurrence of a macrostate P macro, the probability of occurrence of a macrostate P macro is defined by number of microstate in a macrostates, which is also known as thermodynamic probability, and total number of microstates of the system, that is equal to 2 to the power n. Okay, total number of microstates of the system, that is 2 to the power n. So this is our relationship between the probability of macrostates and between the thermodynamic probabilities. Okay, so there is some relation of probability of occurrence and the thermodynamic frequency. The probability of occurrence of the microstate is given by the probability of microstate. We also denoted here the probability of microstate. The probability of occurrence of a microstate is given by 1 divided by 2 to the power n for n number of particles, and because 2 to the power n gives the total number of microstate for n particle to be arranged into 2 compartments. We consider here only 2 compartments. So now we say that P macro, probability of macrostates, is basically thermodynamic probability into P into, yes, right, microstates, because this 1 by 2 to the power n is also determined by P microstates. So this is the relationship. The probability of macrostate is equal to the multiply thermodynamic frequency into probability of microstates. Okay, hence the probability of macrostate is proportional to the thermodynamic probability or thermodynamic frequency, and is given by the product of thermodynamic probability of the macrostate and the probability of microstate. So this is the relationship between and the concept of thermodynamic probability and the concept of macrostate and concept of microstate.